again with Maurice Peoples, and we're going to be talking about soil samples and understanding them and what we can do with them. Thanks for coming.
Okay. Um, Soils are, you hear the old saying, it's not dirt, it's soil. And
Right.
soil is because soil is a living commodity, okay? It's composed of inorganic matter and organic matter. Organic matter is anything that's died and broken down that was once living. And you have microbes in those soils and different creatures that break down that organic matter to supply nutrients and so forth to the plant material.
Mm-hmm.
Okay. Um, Soils are composed of basically three elements. One is sand, and sand is the largest particle size in the soil. Um, Silt, which is the next medium size um, particle in the soil, and then you have clay, and clay is the smallest. Okay, um, and organic matter is the smallest part. Those are the two smallest particle
So
sizes in the soil.
what's the difference between the humus and the silt?
Well, humus is an organic matter.
Mm-hmm.
Okay, that has been like when you do composting. Okay, you get it to a certain level, or even in nature, when organic matter breaks down, humus is the farthest part of the breakdown of that organic matter.
Okay, is that
Still,
what's mainly on the surface? Like you go into a forest ground, you know, and you've got this layer of really dark material that's very loose.
humus is probably going to be farther down because it's the oldest.
Okay,
So it's been broken down. Okay, so the newer stuff is got to break down. So humus is going to be farther down. Silt is a mineral, just like sand and clay. They're
okay, okay,
broken down there. Okay, that's what that is. So um, if you do like a jar test or whatever
right.
to see what your soil samples are, okay, sand is the heaviest, so it's going to settle out first.
Hmm.
Then the silt will settle out second, and clay will be the last thing to settle out. It'll be on top.
Okay, we've done those. We've done the jar test with the water, so
Okay,
a lot of our
okay,
people understand that. You know,
okay,
and then we
and
also,
that's
yeah, then we had floaties too.
okay, okay. So clay and organic matter, okay, have negative charge ions on their sites. Um, and the negative charge ions, okay, will attract and hold positive charged ions in the soil.
Okay.
Okay, just like a magnet. Okay, um, and what we call it the cation exchange capacity,
Okay.
and that's the amount of nutrients that a soil can hold. Okay,
Oh.
on your site.
Okay.
Okay,
So depending on that balance would then determine what nutrients can be held. Is that correct?
correct,
Okay.
correct.
Okay.
Okay, so sand has the least amount of sites. Silt has the next least amount of sites, and clay has the most amount of sites on its surface to hold nutrients.
Okay.
Okay, um, And you would think it would be the other way because sand is a bigger particle,
Right.
but it isn't. It's just, clay is so small and it's so tight that it holds a lot more nutrients than what sand or silt can.
Okay. Okay. Very
Okay.
interesting. Yeah.
So,
Now,
the sire,
so
go ahead.
I'm gonna interrupt you a couple times here because this is one of my favorite subjects. Okay, so
Okay.
okay,
Okay.
so we're looking at this magnetic field basically with the positive and the negative ions. Okay, now where does uh, uh, where does the electric conductivity come into play? Because that's not the plant electric conductivity, is it?
Well,
Or is it part of it?
I would imagine that is part of it.
Okay.
When you sent me the soil samples or the soil test, you have conductivity on there.
Yes.
Um, the conductivity could also be, and when we get our soil test, it doesn't say anything about conductivity on our soil test. Um, but depending on what we call base saturation in the soil, is the amount of nutrients that are in the soil.
Okay.
And depending on what that base saturation is and what those nutrients are, depends on what we call a buffering capacity.
Mm-hmm.
And that could be what they're referring to as conductivity. The
Okay.
buffering capacity, okay, as far as you being able to change the pH in the soil.
Okay.
Um, Depending on what that capacity is, it could be more difficult or less difficult to actually change the pH of your soil.
Okay. Okay.
So what's your other question, sir?
Well, no, that was it. The electric conductivity is something I started to learn about back in Ohio, and it's in a relation with the plants and the organic matter. But what I wasn't so familiar with was this balance with the positive ions and the negative ions because it seems like there's several things going on here that really comes down to life in the soil.
Correct. Correct.
Okay.
So, like I said, um, when we get tests, they send us what our CEC value is in our soil test here in Ohio.
Okay.
And that's the cation exchange capacity. The higher the CEC level, the more nutrient rich your soil is.
Oh, okay.
Okay. On your soil test, they don't, and we'll get to that. They don't give me a number like that, a CEC total value on your soil test. So we'll get to it. We'll talk about different things on your soil
Okay.
test.
Okay.
Okay. Um, so common cations, okay, um, in the soil are, excuse me, the acidic ones are hydrogen and aluminum.
Okay.
Okay. The alkaline ones are um, calcium, magnesium, potassium, sodium, and ammonium.
Okay.
Okay. Now, anions have a negative charge in the soil.
Mm-hmm.
And the common ones of those are um, chlorine, nitrate, which is nitrogen, phosphate, and sulfate.
Okay.
Okay, so those have the negative charges. Now, one thing affecting soil pH is if you have more hydrogen and aluminum cations in the soil, you're going to have an acidic pH in the soil.
Okay.
Okay, if calcium and magnesium are higher, you're going to have a
Alkaline.
more alkaline soil.
Okay. Okay.
Okay, so they displace each other and so forth in the soil. So one thing, if you have an acidic soil, then you're adding limestone, which is calcium, and you can get a limestone with magnesium in it, and those are going to displace the aluminum and the hydrogen ions in the soil and raise your soil pH.
Okay. You when you say displace, what's actually happening?
They could be actually combining with each other to displace um, some of the soil. It could also be making the soil water more soluble for the hydrogen
Oh,
and aluminum to dissolve and move out of the soil.
okay. And so if you have harder water that you're irrigating with, you're potentially you're going more alkaline, right? Because of
Correct.
okay.
Correct. Okay.
Okay.
Okay. And the same thing with some of the fertilizers that you're using, they're going to make the soil more acidic over time.
What about
Okay.
salts? Salts with the commercial fertilizers. Is that an issue?
Um, are you thinking like potassium,
Yeah.
which is a salt?
Yeah.
Um,
Yeah. Yeah. I mean,
okay.
when
No, that
you know how everything's NPK, which that's not
well,
the all.
it's not so much salt as
Okay.
being an issue because those are going to be soluble salts in the soil. But
Okay.
the big thing is sodium. Okay, sodium is a salt,
Yeah.
but sodium is the one that causes issues with soils.
Okay.
Okay,
Is that a buffering?
no, no,
Is that a buffering problem as well? The sodium?
um, I'm not for sure on that.
Okay,
Uh,
because some people talk about the salinity in the soil, and
right,
and I haven't seen a whole lot of salinity values in a soil test.
correct. And I haven't either. And that's what I'm going to say. More where we're concerned with the salt as far as the fertilizers themselves is more burn potential.
Right,
Okay.
right, like
Okay.
green versus aged manure.
Correct.
Okay,
Okay. Okay. So there, but the sodium issue is more of an issue with like um like you said, salt along driveways or
yep.
sidewalks or whatever. And then you can put a product down called gypsum,
Hmm.
which is calcium.
Right.
Okay. The one thing about gypsum is it doesn't affect soil pH, but gypsum will
Oh.
combine and move sodium out of the soil.
So these people that throw pieces of drywall in their soil, they're not affecting pH, correct? Because that's gypsum.
Yes. Yeah. Not
Okay.
the greatest for other reasons,
Well,
but yeah.
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 No, no, I get it, but I know so many people that they'll crush up drywall and put it in their compost and put it in their gardens, thinking that they're adding alkalinity to their acidic soil, and gypsum doesn't do anything for pH.
For changing pH.
No, and it can
Yeah.
actually kill other microbial life.
Correct. You're getting too much in there.
Yeah.
Yeah. So uh let's see here. Um
Yeah, I don't mean to throw you off. It's just like I said.
no no
This
no 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 no. I think like I said, we kind of talked about it, hydrogen and aluminum versus calcium and magnesium and their relationships and so forth to being an acidic soil versus being an alkaline soil
Okay.
and so forth.
So now
So,
with that, I'm going to interrupt you again. Okay. So
mhm,
we've talked about this before, like especially in the microclimate and stuff. It's like, okay, you get these test results, which we're going to get into in more depth. You get these test
uh-huh,
results, and academia gives you this recipe. They give you suggestions.
hmm,
Do this, 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 this. But the suggestions of the recipe isn't necessarily in accordance with what you're planning on growing.
correct, correct. Well, it's supposed to be because when you send in your soil sample, you're supposed to be telling them, okay, do I want to be growing blueberries and raspberries, or am I going to be doing a garden or a vegetable garden, or am I going to be doing a
Brassicas,
perennial garden,
yeah,
or am I doing turf, or am I doing trees and shrubs?
pasture, yep.
Pasture. That's why they are supposed to send back recommendations for actually what you're trying to grow in that
So
particular spot.
that's very important that when you send your sample in, you are clear with them what your intentions are for your.
Right,
Okay,
right, all right.
great point.
And and to get on that a little bit, back in 1940, a Dr. F. Baird, um, he did some soil testing. He was in New Jersey. He was at a coastal site, sandy soil. And what he did is he went in and he lined the area um, to raise the soil pH to a certain level. And then he um, did the correct fertilizing that he thought he should do. And then over a number of years, he raised crops. And when he got the ideal what yield and so forth, what they thought they should be getting, then they went in and he tested and he said base saturation for the optimum crop level should be 5% hydrogen in the soil, 3% potassium in the soil, 15% magnesium in the soil, and 70% calcium.
Seventy
Okay,
percent.
70% calcium in the soil. Okay, so that was basically, he was like trying to get pH, of course, up to a certain level. Now, this is the issue that some people have because now people, well, that's how they come up with these numbers as saying, well, you should have this amount of magnesium in the soil, you should have this amount of calcium in the soil. They're just going in and they're saying, okay, we have very good crop production. This is what the soil looks like. So this is what we should try to be shooting for that particular crop.
Okay.
Now, other people have gone in and done testing and they say, okay, this is fine, but they've gone in and they've tried to make changes to the base saturation and they didn't see any significant differences as long as soil pH was adequate and nutrient levels were adequate. And that's all that they're pushing for. They're
Okay.
not like necessarily pushing for certain percentages in the soil.
Okay. So back in Kentucky, working with the farmers there, and I will call their soil dirt. It's not soil, but that was always their focus, was just all those basics, because what they were doing, I always called it hydroponics in dirt. They were, they're growing corn, tobacco, some are growing canola, um, and soybean. That's it. All they cared about was getting a crop. They didn't even care about the nutritional value of the crops or anything else. So they hadn't even seen earthworms in a couple generations in their dirt, and you know, but they were successfully growing soybean and corn. Yeah, I mean, they were getting crops, and
Uh-huh.
tobacco, and
Yeah,
then they rotated, of course, field by field.
right.
So they were successfully getting that, and yet, all said and done, their dirt was not soil. It was not in balance in any way, shape, or form. It was just put the chemicals in there and then water it and plant it. Plow it, chemical, water, plant, water. You know,
And they're being successful.
semi successful
Yeah.
because
Hmm. Yeah.
because now they also they just fight pest problems and blights now.
Right. Right.
Even with the GMO stuff that they're doing, they're just fighting this stuff because everything's so far
Still,
out of balance.
I was gonna say everything's so imbalanced and
Yeah,
so forth.
yeah,
Yeah. So they don't have some of the natural things helping them out with some of the other things like critters and disease and so forth.
yeah. There's no microbial life in their soil.
Right. 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 So and so once again, when we're talking about base saturation, uh, it's just referring to the number of cation exchange sites
Okay.
uh, in the soil. Um, if you wanna put up that first soil test,
Okay.
okay. So so the ideal garden soil, okay, is going to be 25% air. It's going to be 25% water. It's going to be 45% minerals and 5% organic matter.
Hmm.
Okay. Now, when you look at your minerals, sand, silt, and clay, it should be basically 1/3 of each one. Okay. So that's what we call a loamy type soil.
Loamy.
Okay.
You said
A
loamy.
loam,
Okay.
loamy. Yeah. A loam soil. Okay. And you can have all kinds of, depending on what those ratios are. You can have a silty loam. You can have like a clay loam, but
It just depends on what is dominant.
correct.
Okay.
Okay. And so, um, looking at this first soil test, um, it has, okay, when you do a soil test, they don't test for nitrogen in the soil, number one, okay, because it moves so rapidly. You can lose nitrogen to volatilization, where it's hot out in that day and it evaporates and it leaves the soil. It leaches out of the soil pretty rapidly. Um,
Which is our
so
biggest problem here is the
yeah,
leaching.
so they don't test for it anywhere.
Okay.
Okay, they just make recommendations according to what you're saying you're trying to grow, and they kind of look at your pH and so forth, and then they tell you how much nitrogen to put down. Okay, um, per application or whatever. So the first one, it says, uh, of course, there's no reading for it, so they're telling you to put down 1.25 pounds of nitrogen per 1,000 square feet, which is fine. The next, phosphorus the level is high.
Okay.
So you don't need to put down any phosphorus or so.
Is it a problem to have
Potassium,
phosphorus too high?
yes, you can't get phosphorus too high because once again, it can displace other nutrients and so forth in the soil.
Okay.
Phosphorus takes about 20 to 25 years to leach 1 inch in the soil.
Oh
So
my.
once you put it in the soil, it really doesn't move very far in the soil. Where potassium and nitrogen both leach pretty rapidly.
Okay.
Okay, his potassium level um, is was very low, so they're telling him to put down 2.9 pounds per 1,000 square feet, which is fine. His magnesium level is um, medium, but they're asking him to put down a quarter a pound of magnesium per 1,000 square feet. So if he wants to put magnesium down, well, what do you think he can put down for that?
I don't know. What?
You could put down magnesium sulfate,
Okay.
but his pH is like 6.8, and he's got another one that says 6.1, and I'm not for sure why they have two pHs listed there. There's different tests that you can use
But they're not
to
specifying on there that they used a different test.
right. They just say saturated pest extract for the pH one. Um, so I don't know where he's at on that.
Okay.
We usually just get one pH period. Okay, when
Okay.
we get our soil test. Okay, so he's got two. But the other thing is he could put down Epsom salt. Epsom salt is magnesium. So they could use Epsom salt if they wanted to put Epsom salt down
Okay.
to to raise some of that in their soil.
Now I heard that horse manure is higher in magnesium.
Um,
I had a guy
it
tell
could
me,
be
yeah, yeah, I had an old farmer one time tell me, you got a soil test back and it had this magnesium, and he says, well, they used to have horses on here,
on the farm.
on the in the pastures. He said they had horses
Yeah,
here because your magnesium's so high. I,
it. We'll go over that. I researched that a little bit, and I don't remember what the answer is
okay,
on
okay, yeah,
that.
no
When we get
problem.
back
It
into
was just fascinating to me. He goes that this used they used to have horses, and yeah, they did. You, you,
right,
you know,
yeah. So when we get into like fertilizer and amendments, we'll go over that.
okay, great,
Okay.
great.
Um, um, they have sodium on here, but it's very low, so he doesn't really need to worry about sodium and so forth on there. The other thing, they have boron on here as being very low. Um, it's exceptionally low.
Hmm.
Okay, so boron is one of those micronutrients. Um, don't need a lot of. They didn't make any recommendations on it. So, but if they wanted to try to raise their boron level in the soil, you remember 20 multein
Uh
borax?
huh.
That's boron.
Well, I do. I don't know if a lot of our people do, but yeah, yeah. Borax is boron, and it makes your clothes much whiter. Just so you know.
That's right. So they could use that. Um, and you have to be careful with it because it's only needed in small amounts, but it's important for I'm trying to think here real quick. Um, oh, for carbohydrate production in plants. Okay.
Okay.
Um, for sugar translocation in plants, and it's important for seed production in
Well,
plants.
that's all three very important things
Yeah,
when you're
very
growing a
important.
garden. So that's an easy one in a garden setting, not necessarily like in a huge pasture. But
Correct.
if you're doing a garden, getting boron in there is not very expensive. Just like you said, simply using borax.
Right,
Yep.
right. And you don't want to use too much,
Yep.
but yeah, because it can be toxic if you get too much in there. But if they wanted to try to add some, they could add some. But they're not making any recommendation, and so maybe the extension service person could say, "Hey, this is why we're not making any recommendation for the boron, because even though it's low, we don't necessarily care about that. It should be fine." So that's something that
And again,
the
that's gonna,
homeowner can research.
yeah, again, that's gonna be based on what are your goals. What are you
Correct.
what are you trying to
And what
do?
you're growing.
Yep. Yep.
Right.
Which is
Right.
huge. Yeah, and so next episode we're going to get into the amendments, right? We're going to
Yeah.
talk.
Yeah.
Okay. Okay.
Okay. So then the next thing is the textorial analysis test, which tells you what type of soil you
Okay.
have. And he's got 93% sand, 7% silt, and no clay at all. Okay.
Yeah.
And so you got a sandy soil, which you knew. You
Yep.
got sandy soils
Yeah.
there. Okay.
We
The
mostly do
other
here.
the other thing is the organic matter was 0.63%. Okay. Sand doesn't hold any nutrients, and everything is leaching out.
Yep. It doesn't
Okay.
hold anything.
Right. And so it didn't hold water. It didn't hold, like you said, it didn't
Yep.
hold anything. So that's why the organic level is so low. And then you go to which I was surprised. So then you go to the other salinity test and so forth. And this is where um, he's got potassium at 48 parts per million. Okay. On our soil test, we show it shows it at 1 to 5 parts per million is what we're looking for. Calcium at 106 parts per million, and for us, it's normally 40 to 80% parts per million. Now the calcium level up top is on the high side. So 100, and this is parts per million. This is per acre and so forth.
Right. Right.
Um,
Well, it's
and the
interesting. His
past,
calcium's high, but his pH is low.
correct. And that's the thing that, like, when I'm looking at it, I'm just like,
What?
the wheels are turning,
Yeah.
and you don't want to. So how you? But like I say, but they have two different pHs on here, one 6.8 and one 6.1.
Right.
So I don't know what the two.
Okay.
Okay, I don't know what the two. So
The six
yeah, the
point
six
eight isn't.
point eight makes
That's not horrible.
no, and that makes sense to me with the calcium level and so forth.
Yeah.
Um, the magnesium is at 27 parts per million, and for normal, it should be between 10 to 40 parts per million.
Oh.
So you're fine. You're in the middle. You're 27, but that might be why they're saying, okay, if you want to add a quarter of a pound of magnesium, you could raise it up a little bit more. And that's where, like I said, that's where you're coming in with the Epsom salts or whatever, if
Okay.
you want to put that,
Okay.
to kind of raise it a little bit as far as that goes.
Okay.
Um, the next one um, is fairly similar because they're from the same property. Um, and let me back up real quick before I move on. When you look at calcium to magnesium ratios, the ratio of calcium to magnesium should be 6 to 10 to 1. Calcium should be 6 to 10 higher than your magnesium reading, and so
Okay.
forth. Um, Magnesium to potassium, okay, should be a ratio of magnesium 2 to 1 to potassium.
2 to 1.
That's kind of what we look for.
Okay. Okay.
2 to 1.
Okay. Well, we've got
So those
Maurice.
are those.
We've got about 1 minute left on our timing for this.
Okay.
Okay. So
Okay.
so we've got a few more line items to cover on the test, right?
Mm-hmm.
And
Right. Just and the other. I was just going to say the other soil sample is very similar to the other one. The only difference is it had its pH was 7.2, and the other pH on it was 6.9.
that's pretty
Um,
close.
but
Whatever
all
that
the
means.
other readings were pretty similar.
Okay.